Okay, this video is really important because I'm going to illustrate a class and an object. So you've heard the term object-oriented programming. That means that our programs consist of different objects. So to know what an object is, we need to understand what a class is. So you've already seen a class before. We've already had a public class, whatever. And we usually had that public static void main string args method in there. This one's a little bit different. We're not going to have that method in there. This is a class definition. So we're going to actually create what it means to be a circle. Okay, so the different characteristics of a circle, the different methods, which would just be what a circle could do or what we could do to a circle. We're going to define that in this class. Now, the analogy is a cookie cutter versus a cookie. When we're creating the class, we're creating the cookie cutter, defining what a circle can do, what it is. When we actually create a circle object in another class, that's the cookie. So when it's also called instantiation. We instantiate an object, which just means create an object. Okay. So right now we're going to determine what it means to be a circle. So first we'll start off with the characteristics. So we're talking about the Cartesian coordinate, xy plane. So we need an x and y coordinate for the center, and we need the radius, how big the circle is. So if we know where the circle is centered and we know how big the circle is, that defines the circle. So our characteristics are called fields, or sometimes called instance variables, which means they'll be variables that apply to an instance or a particular object. Okay, so right now I'll call private int x coordinate, private int y coordinate. Now those could also be doubles if you wanted the xy coordinate to be a double. This is just an illustration, so I'll create all of these, even the radius, to be integers. So all three values have to be integers. Okay. Now we make our fields private. We'll talk more about that. But in AP Computer Science, basically we'll create our fields private and our methods public. It helps us to establish something called encapsulation, but again, that'll come later. So we have three fields that are all private. And the next thing I'll do is called a constructor. And a constructor is going to have the same name as the class. There's no return type, not even void, just public circle. Okay? So I'm going to create two different constructors, so they'll kind of be overloaded. So the first one will be a default constructor. Default means I didn't pass it any parameters. This would just be, I could create a default circle. Okay? So the main purpose of a constructor is to initialize the fields. I have three fields I want to initialize. Let me let the x coordinate be 0, the y coordinate be 0, and the radius be 1. So basically that's the unit circle. That's our default circle. And a lot of times it's useful to have a default constructor just for that. It's not necessarily all the time, but it's no args or no parameters. It's sometimes called the default constructor. The other constructor that I'll do, notice it has the same name, public circle, but this time it'll accept some parameters. This is the initialized constructor. So I have three integer fields. I'll pass three integers. Now, x, y, and r only live in this method. The scope means they're only defined in this method right here. So if you talk about x and r or y later on in a method, the compiler's going to say, I don't know what you're talking about. So we can refer to these, because notice the scope of these fields, from that brace to that brace. So they're variables for the entire class. Okay. So what the purpose here is, I want to create the x coordinate to be x, the y coordinate to be y, and the radius to be r. So now in another class, I can create a circle by telling it, okay, I want this x, this y, and this r. And it would assign those to the three fields. Okay? So those are our two constructors. It's also common for us to have accessors and modifiers. Now, the first one I'm going to do is, these are private variables. Private means they're defined in this class. I can access X coordinate in the circle class. But if I'm outside of the circle class, I don't have access to X coordinate. So what we do is sometimes we supply an accessor method, which would just be, okay, if I'm in another class and I want to access the radius, it would return an integer. I don't need to pass it anything, any parameter. It would just return the radius. That's called an accessor. Okay, it's a private variable. But with an accessor now, I can access its radius. Now notice, it would be common to create an accessor for all three fields. I'm just going to do one here to illustrate a point. Okay. Another common thing to do would be a modifier. So if I want to actually change the radius of an object, then I would have a set radius. Now if I'm going to change the radius, I would have to also pass a new variable to tell what the new radius should be. Okay, and that would just be radius equals r. Again, that is called a modifier. Okay, so those are common. And I'm only just doing it for the radius. It would be common to do both accessor and modifier for all three fields. It's not necessary, but that would be a common thing to do. Okay, I'm just going to create a couple more variables, or methods, just to illustrate out in another class. Okay, so the first one I'll do, let's say I want the area of this circle. Remember, it's on the XY plane, but it would have an area defined basically by the radius. Okay, so the area would have to be a double. Even though the radius is an integer, we're going to multiply it by pi, which is a double, and so we need it to handle that precision there. So public double get area. We don't need to pass it any parameters. So we would return math.pi, which I don't even think we talked about that. That's a constant, which is why it's all uppercase. But it's pi. It's 3.14159 so and so. Okay, so it's hold on the math class, so we can just call it from there. And then the area of a circle with math, or is pi times r, or radius squared. You could do math.pow and do radius and then comma 2. But if it's just to the second power, a lot of times we'll just multiply by themselves. That's pretty easy to do. So that's the area. I'll just compile to make sure I don't have any syntax errors. Looks like we're good. Alright, so the last one I'll do, just to show you another type of variable, would be public boolean. Now boolean, it has to return either true or false. It has to return true or false. So I'll do passes through origin. So there's the circle in the Cartesian plane, the XY plane. It has a center, an XY coordinate for the center. It's got a radius. We want to return if it passes through the origin. Okay. Now, if you didn't know this, not a big deal. This is the equation of a circle. This is more of a math thing than a computer science thing, but that's the equation of a circle. Okay. So C and D would be determined by the center of your circle. That would be our X coord. This would be our Y coord. And if a point passes through the circle, then you could put that point for X and Y, and it would produce a true equation, which would be equal to the radius squared. Okay. So if we're talking about the origin, then basically we're putting 0, 0 in for X and Y. So it basically boils down to is our X coordinate, it's actually negative the X coordinate, but it's going to get squared, plus the Y coordinate squared, is it equal to the radius squared? Okay. So a lot of people when they're first doing these methods would do an if else, and that's fine. Okay. I'll also show you how to do it without it. So this would say if X coordinate times X coordinate, that's X coordinate squared. Remember, it's actually the negative value of that, but if it's squared it becomes positive, plus Y coordinate times Y coordinate equals, Equals equals is how you compare integers and other primitive types. Now you have to be careful with doubles because there's some rounding error for doubles, but it's good for integers. Is it equal to the radius times the radius? And if it is, let's return true. We're saying, yeah, that circle passes through the origin. And if not, we can just say else, return false. Okay. Now, there's an easier way to write that, but we'll get into more of that when we get into the actual boolean thing. So let's make sure this compiles. It does. Okay. So let's go to a tester class. And I'm going to have a part 2 to this video with dealing with classes because it's so important. But I'll at least start it here. So I'm in the main method, and what I want to do is create I'm going to create a couple of circle objects. I'll call circle A new circle. Now notice I didn't pass it any parameters. Okay, so it's the unit circle. 0 is the x coordinate, 0 is the y coordinate, 1 is the radius. I'll create a circle B. Now, this is the x coordinate, this is the y coordinate. That's the radius. So, this is, the center is 3, 4 in the first quadrant, and the radius is 5. So, that actually will pass through the origin. If we wanted to test that, let's try another one that will not. 3, 4, 6 will not. Okay? So, a couple things to illustrate. These are all objects. So these are like the cookies. The circle class was cookie cutter, defined how everything was created. These are actual objects. Okay, they're in the main method because I'm going to do some stuff with them. But these are objects. Okay, so I'll pick up in the next video.